Bienvenidos, Ushamdi, and welcome. CMIT 454, sections 6380 and 6382 for the first 8-week term of the spring 2018 semester at the University of Maryland University College. This is the CCNA Security version 2.0 course from the Cisco Networking Academy. And this evening's Packet Tracer tutorial and solution set is going to be on Packet Tracer activity 4.1.1.10, where we're going to be taking our first look at extended IPv4 ACLs. And there are a number of activities that we're going to be working our way through with extended IPv4 ACLs. So let's go ahead and jump in here. All right, so here we have our topology, and the first thing that I noticed when I pulled this up, and this is definitely worth noting, is that there is clearly an issue, and that right there is a mistake. That has to be a mistake. And what I mean by that is it says 172.22.31.0/26, that is the subnet here that the server sits on. But when you look over into the addressing table, right, take a look at what it says, server 172.22.34. So this entire activity is based around the 172.22.34.0 network that has been subnetted, right, into a 26, a 27, and a /28. So that is clearly a mistake. And you'll notice it looks like over here when we get down in the FTP part here that they also repeat that they repeat the 34, not the 31. So again, make a note of that, because if you're looking at this, you're going to think to yourself, well, wait a minute, they're telling me to set FTP up so that I can get to the server, and I'm not using the 31 in the third octet. All right. So let's go ahead and take a look at the scenario that we have here. Again, this is a very easy landing type activity, some low-hanging fruit initially that is not too complicated, but it's a great segue into some bigger conversations on IPv4 extended ACLs. Now, to start the conversation, remember that we've got standard ACLs, right? Whoops. We've got standard ACLs. And the thing about the standard ACL is it is a layer 3 packet filter. And when we talk about access control lists, what are they? Well, they're not stateful. They are stateless. They simply look at every single packet and make a decision on every single packet as to whether or not they're going to permit or deny that packet. And when we're talking about standard ACLs specifically, that decision process is based 100% on a single piece of information, and that is the source address, right? So standard ACLs can only filter based on the source address. And remember, this is stateless. Right? This is a stateless activity. And what I mean by stateless, and let me define that now. We're going to take a look at an ASA firewall here that's got hundreds of connections running through it right now. So a stateless appliance is not keeping track of how many bytes have been sent back and forth. It's not keeping track of idle time, if there's any. It's not keeping track of the source and destination ports, right? All of those things for a conversation or a flow of information are not being tracked, right? That is stateless. It is not keeping any of the state information. It is simply looking at the IPv4 IPv4 header, and it is looking at one thing in the case of the standard ACL, the source address. That is it. And that is a stateless activity. Now we talk about the extended, let me see, my writing pad here is given out on me. The extended ACL, which is a layer 3 and a layer 4, and it can be. It doesn't. It's not inextricably linked. We can simply go on layer 3 information alone. But typically, you see the extended ACL is going to be a layer 3 with layer 4 information added in there. But again, it is a packet filter. That is all an extended ACL is, packet filter. Now, with the packet filter, we can do additional filtering, or we can use additional criteria with which to filter on. I can use the source address. I'll just say SA. I can use the destination address. I can use TCP port numbers. I can use UDP port numbers. So let's say we're doing SSH, right? That's a great example of TCP. What if I'm doing NTP, right? That uses UDP port 123. I can filter on ICMP and all of the different message types. I can filter on just echoes. I can filter on echo replies, right? I think it's packet too big is in there as well. And we'll take a look at some of these as we work our way through. But again, the key takeaway is this is also stateless. There is no state information being tracked, right? Again, just like the standard ACL, the header and then any additional segment, if it's TCP, if we're filtering on TCP, UDP, whatever the case may be, that is what is being looked at, and it's being looked at on a packet by packet basis, and that is how the decision is being made. Now, you may be saying to yourself right now, well, wait a second, Travis. We saw something in chapter 4 that talked about this established keyword. Established keyword. Established, make sure I get this right here. Established. Whoops. ED. The established keyword, and that is stateful. And it is not, right? So we've defined stateful as keeping track of idle time, the bytes, all the things I'm about ready to show you on an ASA firewall. So by our definition, the use of the established keyword was really Cisco's first attempt at providing statefulness to an ACL, right? To an extended ACL. And that's where we would see it, because established is inextricably linked to the TCP protocol, because that is what the established keyword is really saying. The established keyword is saying, I'm going to check these packets or segments as they come through, right? I'm basically looking at the TCP flags that are set. And if I don't see the acknowledgement flag, right? And the acknowledgement flag means that we are either establishing or have established a TCP session, right? Hence the established keyword at the end of the ACL. So if I don't see acknowledgement as a flag in the segment, in the TCP segment, I will drop that traffic. So let me give you an example here, since we're here and this is actually kind of set up kind of nicely. So if I was to position an ACL right here, right, and I was to put it in the inbound direction when I go into, say, IP access group, and we'll say HTTP only, right? It'll be the name of our ACL. So if I said IP access list extended HTTP only, and I hit enter. That's my little carriage return there. It's going to put me under the access list, and then you'll see the NACL for the named access list configuration. There's some stuff here. I think it's access list -NACL. So again, doing this from memory. So, and that's what you'll see, right? And so then this is where we come down and we say permit. And what are we permitting, right? Well, I'm permitting TCP, and then I've got my from. From who in the inbound direction would I be permitting TCP? Well, it's going to be host 172.22, and we said that it's 34, and I believe, oh, it's not 62, I think it is. So we'll just go with 62 because that's in this range here, and it's before we hit that network there. And so we're just basically saying that this is the server, and we're just gonna pretend that that's a web server. So I'm permitting the TCP protocol from host 172.22.34, sorry, that's a bad 4 there, .62 to go where? To anywhere equal to, I could put 80, and then I could do another line after this and say 443, right? But at the end, I'm going to say established. So if I apply this ACL to that interface on this router 1 right here in the inbound direction, the only traffic allowed that's going to allow, right? Because remember, we have that implicit deny any at the end. The only traffic that it will allow is TCP-based traffic coming from that host going anywhere with port 80 as the destination or port 443 if and only if it is established. And again, that establishment means this. So let's say this user right here, he goes to www.widget.com. And that just happens to be this web server here. The first TCP packet, because remember, this is TCP, this will be a SYN packet. And remember, this is in the inbound direction, not the outbound direction. So that traffic's allowed to go through. It gets to the web server, and the web server says, ah, right. So now what I'm going to do is I'm going to go ahead and I'm going to respond to that with a SYN ACK. And there is the acknowledgement that we're looking for, the flag that we're looking for in that response, that initial response from the web server, coming inbound to this port with the ACL that's going to be checking to see, is it established? That is what we are looking for. Okay? And so that's what the established keyword is. But again, even with the established keyword, it's not tracking bytes or idle time or any of that information. It is still a stateless operation that just simply is looking at additional layer 4 TCP information to make a determination as to whether or not that traffic will be allowed back through this interface. And it provides a level of security as well, if you think about it. Because if the ACL right here is saying that I'm only allowing established connections to come back through that port in the inbound direction, that would mean, that implies that if this web server is compromised, and I'll do my best, skull and crossbones drawing here. If this gets compromised, and we've got a bad actor here, and he's trying to initiate SSH exploits or telnet exploits, those are all TCP based. And when he goes to initiate those exploits, which flag will not be in the initial TCP segment? You've got it. The ACK flag won't be in there. And that traffic would get dropped immediately, right? It would get dropped immediately. So again, that is the use of the established keyword. And now that I'm looking at this, I don't believe, and I'd have to double check again, I'm kind of doing this from memory, I don't believe we need to put the equal 80. But I think you do. And again, let me double check on that. I'm not sure if we need to do that or not. So I'll come back to that. But again, that's the established keyword, and that is exactly what it's doing. That ACL right there is going to block all traffic unless it is established, meaning there's an acknowledgement flag in the TCP segment coming back in the return direction. All right. So That's a brief review of what we talked about, or what we read about a little bit in chapter 4. So now let's pull up router 1 here and let's get to work on that first, whoops, and we don't want that, on that first ACL. All right, so let's jump on the CLI here. And let's go from user exec to privilege exec with the enable command. And then we'll type in conf t, and I'm going to sneeze here, hold on. Excuse me. All right, so we get into global config with conf t. Now, again, very low-hanging fruit here because they're literally going to walk us right into the commands that we need in order to be successful here. So we're going to say access list. I'm going to do a question mark, and we're going to see that with the standard ACL, the regular range, and I got to make sure of the wording I use here to make sure we differentiate. So the regular ranges for standard and extended ACLs, for the standard ACL, it's 1 to 99. For extended ACLs, it's 100 to 199. Well, obviously, as time went on and more ACLs were created, the need arose for additional ranges to be added. Now, we don't see those ranges here, but for the standard, the expanded, I need to make sure I stress that word, the expanded range. I don't want to say the extended range because then that gets confusing, because you may think, when I say, oh, the extended range for standard ACLs, and it's like, well, wait a second, you mean standard ACL or an extended ACL in the expanded range? So again, to be clear, the expanded or the additional range that was provided numerically for numbered standard ACLs was 1300 to 1999. And we're going to check this here in a second. And the expanded range for extended ACLs, right? Those additional numbers from which we can choose are 2000 to 2699. And if I come over to one of these routers here, let's check, is this router? Yeah, so we'll check on router 3 here. So if I was to go into global config and say access list, whoops, sorry, access list and do a question mark, we should see, and we do, 1300 to 1999, right? And 2000 to 2699. So those are the expanded range for the standard and extended ACLs respectively. And again, I want to make sure that I'm stressing expanded range, the numeric range, the additional numbers that have been added, so that we don't confuse expanded with extended. And I catch myself doing this all the time. I'll say, oh, the extended range, right? And you certainly could use that, but it may cause some confusion. So I'm going to stick with expanded, right? So what are we being asked to do here? Well, we're being asked to use ACL 100. And what are we going to do? Are we going to deny, permit, remark? Right? It's always good to put a remark in there. This doesn't ask for it. I'm going to avoid it because the scoring engine may not appreciate that and react positively to a comment being put in there, a remark being put in. But you should certainly put a remark in there, like maybe the change control number that you're using, right? So if I was to do this, I would say remark, and then I could put, you know, CCR number 8675309, and then maybe the date 12/26/2017, and then maybe the user ID. Whoops, TP bond fee, and then allow FTP, right? Whatever the case may be. But something in there that someone following you can look back at and say, oh, that's who added it, this is why they added it, and this is when they added it, and here's the authority, and I can go back and maybe look at the CCR to see, was this part of a bigger project? Especially when you're working on the firewall side of the house, you definitely want to put remarks in there when you're working with firewalls that have 5, 10, 15, 20,000 entries. It certainly helps. So we're going to be permitting what? Well, it's permitting FTP, but if I do a question mark, you can see that it doesn't say FTP here, right? So there's a reason it doesn't say FTP, because again, remember, FTP is the application that we're talking about. And so what protocol does FTP use? Well, it uses TCP. So right now, I'm setting myself up. This could be from here on out, it could be for SSH, it could be for FTP, it could be for Telnet, anything that's TCP based, right? But again, we're going to narrow this down and we're going to be using FTP. All right, so we're going to do the network. Now, this is an interesting point as well. So we're going to be doing the network, right? And you'll notice that they show the 172.22.34.64, the network. So they give us the network ID. Now, that's one way to do it. But typically what you want to do, the best practice is you want to be as restrictive as possible, right? And as granular as possible. And one of the ways to do that is to simply do it for only, I'm sorry here, I'm typing in something else. I'm trying to get to that established keyword answer. So you want to be as restrictive as possible. So to do that, what we would want to do is put in the exact IP address of the host, right? Of who we're coming from. And it's going to be coming from PC1. That's the requirement that we're given. So I could say host 172.22.34.66. That was PC1's address. Now that's one way to say it. The other way to say it would be, oh, and it's not going to, okay, there we go. And I'm going to have to pull back the word host. The other way to do it in this exact same, means the same thing as saying host 172.22.34.66, is to do it like this. So you may see it both ways. You may see the keyword host there with just the IP address, the specific IP, or you may see the specific IP in the quad zeros. But again, remember, they mean the same thing. They're allowing access only for that specific IP address. However, here, they're looking for 172.22.34.64, and now we get to the wildcard mask. And again, there's always typically more than one way to do things. This is certainly a way to do it, is to write the binary out. So take the dotted decimal notation of the subnet mask. And again, what we're having to do is for this network here, it's a /27. So I would have to look at that and say, okay, I've got a /27. So that means the first 27 bits, 1, 2, 3, 4, 5, 6, 7, 8, 3, 4, 5, 6, 7, 8, and hopefully this is right in all of them, 1, 2, 3, 4, 5, 6, 7, 8, and then 1, 2, 3, meaning I've got how many host bits? 1, 2, 3, 4, and 5. And remember, we're not talking about that network right there. We're talking about the PC that's down here behind the router 1 terminal screen. So it's certainly an easy way to do it, right? If I know it's a 27, I know there's 5 bits at the end here that are going to be zeros. And so the way that they show you to do it, sort of like a bitwise operation, is to, underneath the host bits, put 1s, and then figure out what would those values be. And, you know, if it's a 1 at the top here, right, it becomes a 0. And I won't fill all the zeros in, but these are all zeros here. And if it's a 0 at the top, it becomes a 1. And then I simply figure out, okay, this is 128, 64, 32, right? So I've got 16, 8, 4, 2, and 1. Well, 16 plus 8 is 24, plus 4 is 28, 29, 30, 31. And that's how they come up with the 31, right? Now, just as easy of a way to do it is to say I've got a /27, and I know that a /27, that these are going to be the bits that are going to be set on the network side of the house. And I'm borrowing 3 bits out over here. So what would that be? 128, 192, 224. Well, if I know 224, if I can figure that out quicker than adding these 5-bit positions together, if I know it's 224 and all of the preceding octets are 255, I simply subtract the dotted decimal, or I should say I simply subtract from an all 255s, 255, 255.255.255, I simply subtract the dotted decimal notation of the subnet mask from the all 255s. And what do we get? Again, and we're saying that, you know, the subnet mask is 255, 255, 255. So that would be the same thing here, the same thing here, the same thing here. So it would be 0. And again, let me put an X here because I'm just representing 255 so we don't write all those out. So it's 0.0.0. And then we get to the interesting octet. Well, what is 255? You subtract 224 from 255, you get 31. So that's another way to work out your wildcard masks. And in both cases, we end up with the same value that we're going to need, which is 0.0.0.31. Now we've got our from. So what we're saying here is any host in that network with PC, or I think it's PC1 or PCA, any host in that network, we are going to allow to communicate with whom? Well, it's going to be that server up there. And now they're putting it in to be specific, right? Because we're trying to crack down. We don't want people to go all over the place. We want to make sure that we limit, and the IP is .62. And again, I could have written it as how you see it here, host 172.22.34.62, or I could have said what? Yeah, I could have said 172.22.34.62 space 0.0.0.0, leaving the host keyword out. Because again, those are equivalent statements. But they want us to go ahead and put the 62. Now, there's the established keyword. So yeah, it's got me thinking here that I don't need to have the port number in there. You can have the port number in there, I guess. But yeah, you could have the port number in there, but I don't think it's port, and maybe it's 443. Again, off the top of my head, I can't remember, but the key thing with the established keyword is it's got to be, there has to be the ACK flag set on the TCP segment coming back. So here we're going to say equal what? Well, equal FTP, right? And I hit enter. All right, so now we're going to create a second access list statement to permit ICMP traffic from PC1 to the server. It says, note that the access list number remains the same because it's all part of the same ACL. So we're going to go ahead and say access list 100. We're going to permit, and again, you can see right here, there's ICMP. So if I do a question mark, again, who's it from? The source. So from whom? They've got us doing it again here where we're going to say the whole network 22.34.64. Sorry about that. I almost put the wrong thing in there. 0.0.0.31. That's our wildcard mask going to, we want to be specific, 172.22.34.62. And that is our server. And so we're permitting all ICMP, right? We're going to permit all ICMP. And we could even be more specific, right? I could say, no, just only allow an echo reply to come back to me and not allow everything. And actually, we're going to do this in the inbound direction, I think, is where we're going to apply this. So let's see what happens here. All right, so there's the ACL. So now we're going to go under interface gigabit Ethernet 00, and I'm going to say IP access group, and what do we say? 100 inbound. So where are we applying this? So I'm applying it here on gig 00, the extended ACL. The best practice, if you can achieve your goal, is to apply it as close to the source as possible. With a standard ACL, it's just the opposite. A standard ACL should be applied as close to the destination as possible. Again, those are best practice recommendations. They are not hard and fast rules that you cannot deviate from, because there will be cases that you'll run into. In fact, some of the packet tracer activities I did for my CCNA course just this fall will show you that there are times where you're going to have an extended ACL and it's not going to be as close to the source as possible. Or you're going to have a standard ACL and it's not going to get placed as close to the destination as possible for whatever reason, right? It all depends on use case, but typically the best case, right, and the best practice is to get the standard ACL as close to the destination as possible and the extended ACL as close to the source as possible. So we're putting it here on this interface in the inbound direction. So let's pull this up and put I in, and we're probably going to see a few points for that, and we do. Now we need to do some testing. So from PC1, I'm going to ping the server. So let's pull our desktop up and let's come over here to the command prompt, and I'm going to say ping 172.22.34.62. Now this should function because we allowed, and we needed the ARP packet to sort out the default gateway for us to get us off of our local network segment, and that was our request timeout, right? We were waiting, and then the ping packets go through, and everything works, right? So everything looks good. Now, can I ping from PC1 to PC2? And let me get PC2's IP, I forgot it, 3498. All right, so can I ping over to 172.22.34.98? Now this is something, and you'll notice here, I don't get a request timeout. I get a destination host unreachable. And that is a type of ICMP reply that you can get back, right? So, and we'll get into this. I'm going to do a supplement on ACLs where we're going to go a little deeper dive into the semantics of ICMP, because typically the security team is going to tell you, yeah, we're turning ICMP off, period, because it's viewed as a security threat. And when improperly configured and deployed, it certainly can be a massive security threat, right? To allow that information to be, gained via ICMP. However, there are things that you can do to mitigate the security threat while still allowing you the functionality and the utility of using ICMP as a network administrator. Because one of the most frustrating things is you go to do a divide and conquer troubleshooting approach only to find out that ICMP and ping has been turned off completely, right? And so that makes things a lot more difficult, because then you've got to start looking at other avenues where if you were to allow the echo replies through the firewall, right, to let those come back in, but don't let echo requests come in, that's a different story. So there are ways to mitigate that. And when we get into the supplement, I'll talk about that. We'll talk about an infrastructure, quote unquote, an infrastructure ACL to protect your infrastructure. Okay. So we can't ping, we get the destination host unreachable because it's being denied by an ACL. And I think when you do this with IPv6, the code comes back, I think it's like a capital A or something like that. And so I'm pretty sure we'll get to see that because there is an IPv6 ACL activity. All right, so now we're going to configure an ACL, extended ACL. And I'm reading here, what are we going to be doing? And this has got to be on... what interface? So this is for PC2. Okay, so it's for PC2. So we're going to be dealing with interface gig 01, but we're still dealing with router 1. So let's transition back to global config. And I'm going to say, oh, I'm sorry, it's a named ACL. So in order to get the named ACL, we want to start with IP access list. And again, I have to not determine, but I have to differentiate between standard and extended, because I can have a named standard ACL just as easily as I can have a named extended ACL. So I have to say, what kind of a named ACL is this going to be? And it's going to be extended because we're going to be using layer 3 and layer 4 information. So IP access list, extended, and then the name. And what do they have in this? HTTP only, I think. HTTP underscore only. And then we hit enter. Now, oh, it's config ext. That's what it is. Config ext for external named ACL is that NACL that you see there. All right, so we are going to permit, and let's make sure we get this correct. So they want to allow, so we're going to permit TCP from whom? And again, they have us do the network here. Again, nothing wrong with this because it lets us exercise, hey, now we're doing it with the subnet with a wildcard mask, and then immediately the 2 is going to be the more specific host statement. So we're getting to use both approaches here. So I'm going to say 172.22.34.96, and that is okay. And so they don't show you, oh, okay, great. Yeah, they show you the subtraction method here. So again, they give us the answer, and it's going to come down to be 0.0.0.15 because 240 subtract 240 from 255, and you get 15. So that's our from. So anybody on PC2 subnet is going to be able to use ICMP to hit host 172.22.34.62, and that is the server IP. Now, if I do a question mark here, you'll notice that we could still go out to the equal, but we wouldn't do that, right? Because we're just saying, and I'm sorry, I actually put the www in here first is what I wanted to do. So we do want to do equal. I was thinking we're at the ICMP piece. So equal www, right? So there's the first ACL entry that's going to be required. The second ACL entry, this is the ICMP one. So we're going to say permit ICMP 172.22.34.96 and again 0.0.0.15. So anybody on that subnet where PC2 resides is going to be able to ping as well as use HTTP to get to host 172.22.34.62. Now it's here, and this is what I was anticipating when I did the question mark earlier. As you can see, right, I can be very granular with what type of ICMP packets I'm allowing to come into this gig01 interface, right? So maybe I only allow, and here's what we'll do. So I'll do this and we'll make it interesting. So they don't have us do this because we're just basically saying, and this is going to be on gig01 in the inbound direction. And please tell me, did I put that other one on gig01? Okay, I did gig00. I just had this fear that I'd put it on the wrong interface. So we've got our ACL. It's all set up. It's HTTP_ only. So let's get into interface gigabit Ethernet 01. And let's go ahead and say IP access group, HTTP_ only. And it's in the inbound direction. So both of the ACLs that we've done are going to be inspecting the traffic as it comes from the LAN segments of the respective PCs into the router in gig00 and gig01. So they're going to have us validate here. So ping from PC2. So let's pull PC2 up here. Oops, sorry. And we want to get to back to the desktop here, and we want to get here. So we're going to ping from PC2 to the server. So I'm going to say ping 172.22.34.62, and we allowed that, and that should work. And as you can see, it does. And then what do they want us to FTP from PC2 to the server? So we're going to say FTP 172.22.34.62. And did we allow FTP? We did not, and we get disconnected, right? So you can see that the ACL is doing exactly what it's supposed to do. Now I'm going to close this. I'm going to open the web browser up, and we're going to go to 172.22.34.62, and I'm going to say go, and we'll probably get, yeah, a little small page. We'll go back, copyright message, right? Okay, so we're going to close that out. Now here's what we're going to do. Remember, when I ran the ping command, and we've got the 100 points, right? And that's great. But let's take this one step further. Let's go a little bit deeper. Let's look at those ICMPs real briefly here. You notice that the ping works. Well, what if I come back over here to router 1 and I say IP access list extended, and we'll give it a name. We'll say ICMP _ reply, right? And I'm going to say permit ICMP from, and I'm going to put the wrong IP address in here. I'm going to say 172.22.34.63, or actually I'll do 61. Because remember, the server, and I'll use the quad 0 method here, and I'll say going to host 172.22.34.98. Let me double check. I think that's PC2. It is PC2. All right. And here's what we're going to do. So we're permitting ICMP from a bogus web server address to PC2. And here's where we're going to say equal, whoops, and what did I leave off? Oh, I'm sorry, just echo reply. Sorry about that. And I'm going to say echo dash reply, right? So that's the first statement in the ACL that's going to be checked. It's going to check and see, is the traffic, is it ICMP traffic that is originating from 172.22.34.61, which is a non-existent address, going to that host that's echo reply. So let's go into interface gig02, and let's say IP access group, and what did I call it? I think ICMP _ reply is what I called it. There we go. And I'm going to put it in the inbound direction. So again, when we say the inbound direction, we're saying it's coming into the GigO2 interface this way. So as soon as I do this, right, remember what's implicitly at the end of every single ACL, whether it's standard or extended, whether it's IPv4 or IPv6, there is a deny any at the end. So when I hit enter there, all I'm allowing is ICMP echo replies, but I'm allowing them from that host. And that host doesn't exist. So now, let me ping and let's see what happens. And what is it that's wrong here? Yeah, the requests are timing out. And here's why it's timing out. Because I'm not seeing it as getting blocked going to the server, right? It's getting blocked coming back. The echo reply is being blocked coming back to me. And so let's go ahead now. Let's kind of clean up our ACL here. Let's say IP access list extended. And this is a great opportunity to take a look real briefly at how I can go ahead and insert or edit the ACL that I've already created. Because I can put the sequence number in. By default, do show IP access dash list. And what did I say? ICMP underscore reply. So there's my ACL, right? So I can put a statement before that statement. I'll put 1, right, for statement number 1. And I'm going to say permit ICMP from host 172.22.34.62. So now I'm going to put the real server address in here, going to host 172.22.34.98 echo reply. So I've just added that to the ACL. So now I'm allowing the echo replies to come back from, because remember, this is not a session. There's no session that's set up here, right? These are independent packets that are not part of a flow from the perspective of the ACL. So now I'm going to ping, and now it works because I've inserted a statement allowing the echo reply to come back. But all other traffic, with the exception of the bogus permit statement, all other traffic is being denied. So now if I come back to I go to PC2 here, and let's see, is this going to work? Remember the comment I just made about ICMP? It doesn't set up, it's not connection oriented like this is, 62. Like HTTP is. But what happens here? Do I get anything back? I don't, because all traffic is being blocked coming back inbound, right? So I see nothing. Well, let's go ahead. Let's put another statement in here. I'll say statement 99, right? Just for this, put something in here, something fun. So I'm going to permit TCP from host 172.22.34, the server, which is also a web server, going anywhere if it's established. And there's the established keyword. So what does our ACL look like right now? So let's say do show IP access list. And what did I call it? And now the name really doesn't apply anymore, right? ICMP reply. But take a look at what we've got in here. So I'm allowing any TCP traffic coming from .62 to go anywhere as long as the connection has been established. So let's come back here. You see we timed out? Now it works, right? Now it is working. There is the established keyword in action, right? And again, this answers that question, which I desperately was trying to recall. Can you put the port number in there? You probably could put a greater than 1023 because it's going to be returning to one of the randomly high ports. I don't think you'd put 80 or 443 in there as I demonstrated. But again, you don't need to put anything in there. If I'm just going to say going anywhere, right? As long as it's established, it will now be able to function because, and you can see we've got some matches, right? It's going to show me how many matches we've got. but it's going to be allowed to function because the SYN packet that initiates the HTTP session will be responded to with a SYN ACK. And then all other conversational pieces of the conversation will have acknowledgement packets coming back. So those will be allowed to come back through. All right, well, this is going to wrap up our first conversation on extended IPv4 ACL. So to review, we talked about using the host keyword and how that's equivalent with the quad zeros. We talked about the differences between standard and extended ACLs. We talked about the expanded ranges for both. And most importantly, we talked about, like I said, the most important takeaway here is that ACLs, when not on firewalls, are nothing more than packet filters which are stateless. They are not tracking state information. They are simply looking at the layer 3 information only if it's a standard ACL, and layer 3 and or layer 4 information if it's an extended ACL in either the TCP header or the IP header, right? That is what is being looked at. And that is a stateless activity. It is a stateless execution that takes place when we're talking about ACLs. And then finally, we talked about the established keyword that you'll see at the end of some ACLs. Typically, or I should say, it's going to be for ACLs that are using TCP, because what does that established keyword demand in order to allow that traffic to come back through where the established keyword's being used? It requires the acknowledgement flag, and I also believe the reset flag is allowed back through. I'm pretty sure it's the reset flag. It's either that or the fin flag, the finish flag. So there's another, but the ACK flag is the one that we're most interested in for our conversation. But there is another flag that is allowed to come back through. It's either reset or fin. So again, I thank you for watching. I hope this has provided some clarity around extended IPv4 ACLs, why you would choose standard, why you would choose extended, how we create them, the differences, the similarities, and that established keyword. And the fact, again, they are stateless. They are not like a firewall. All right. Thanks for watching, and I will talk with you soon.